Hey friends, this is today's POTD problem of Geek for Geeks, which is easy one, linked list matrix. So what we have a matrix of size n into n, which is nothing but a square matrix, and our task is to construct a 2D linked list representing the given matrix. Okay, so for suppose this is the matrix, and we have to represent that matrix into a 2D linked list like this. And before that, this is the structure of the linked list, right? So our linked list has input data and two nodes, like two pointers. So one pointer is to point the right side value and another pointer is to point the down element, right? Down element of the matrix, right? Hope you understand the question. So let's try to debug the test cases. So what we have, suppose this is a matrix. So 3, 4, 5, 6, and 7, 8, 9. Let's try to understand with just 2 into 2 square matrix. Okay. So, so we have a matrix of 2 into 2, right? Uh, so yeah, 2 into 2. So, and what is the output for this matrix? We have to convert into a 2D linked list like this. So far, where the each element can point its right side element and its down element. So right side element and its down element, right side element and down element. As there is no right, so now it points to null. It also points to the null. Yeah, this is also points to the null, and this is also points to the null. So this is the matrix which we have. So what we are actually doing, we have to convert the elements of the matrix into the nodes first, and then we have to establish the links between them, right? So for suppose here n is 2 and like so n is 2, so that means here 0 1 and 0 1. So we have to write a for loop, so from 0 less than up to n, right? So 0 to n, not equal to n, 0 to n, that means n minus 1, right? So and we have to iterate over the for loop over the matrix. So in order to first establish the nodes for that matrix, so uh, yes, initially we have to take a data structure which is vector. So vector which like vector of vector, which is nothing but a 2D array, but here the elements of the 2D array are what? Nodes. So each node has three parts. One part is for data and another part is for to store to point the down element and to point the right side element, right? So this is what we have to do. And so let's see the code. So here see, I'm taking the n value with the help of the matrix size, right? So matrix size here, if I have elements like 1 2 3 4 5 6 7 8 9, so this is the matrix element, and let's say this is the matrix M. So if I type like M dot size, then I have the number of rows which I have in this matrix. So like it basically gives the total number of rows present inside the matrix. So in order to extract the total number of columns inside the matrix, we have to write it like this: dot size. So m of 0 dot size, which gives the columns. So basically it take the particular row, like m of 0 is nothing but first row, right? And it gives the size of this first row. So 1 2 3, so here the size is actually 3. So this is syntax to get the number of rows, and this is to get the number of columns. As here it is a square matrix, so we can use any one of the technique, right? So if it is null, then we have to return null. So why null? Because we have to return in the form of node, in a form of pointer. So otherwise, what we have to take? We have to take a vector of vector, which is nothing but a matrix, but whose element has to be a node, right? So this is what, and size is n, and for all columns, basically, uh, we have to put a null. So null as a pointer. So it points to the null like that. So see here, it points to the null. It points to the null. So we have to initialize the vector as like this. So like this. So and but here each has null as pointer, null. So that means of n size. So of n size and n number of column elements, we have to fill the node with null value, right? And then we have to iterate over the matrix in order to put the matrix element into our node matrix element. So this is our node matrix element, and node matrix, we have to create a node for that, right? Not to put the element into a node matrix element at particular index, so which is nothing but I is equal to j, right? And so after putting the element, we have to establish the relation between them. So like we have to give the links between the elements inside the matrix. So for that, we have to again iterate over the matrix element. And so for each element, we have to check whether it is not the last element. If it is not the last element, then we can increment that value, right? So for this, see here. So let me take I is the row, and j represents the column. And if I, that means row is not actually the last row, uh, it when it is not the last row, then we can actually increment our I pointer. So that means we can actually point to the right side element. That means, so whenever I is actually less than n minus 1, so which is nothing but last element, n minus 1 is the last element, right? So then we can increment that. So then we can actually increment the right pointer, right? So see here, j represents the right pointer and I represents the left pointer, down pointer, right? So I plus 1 and j plus 1. So uh, and for what we have to establish in for this node, so node of right, so node of right is equal to node of what is this element exactly? Node like on we our vector is node mat, so node mat of I j plus 1, and this one is node mat of I plus 1 same j, so like same column, right? So j, but I row is changed, so I plus 1, so I plus 1 j, and here j plus 1 I, which points to the right of the I j and points to the down of the I j for the current element when that is not the last row, and when it is not the last column, we have to perform this operation, and after that we have to return this first index, right? So which is nothing but the head. So hope you understand this one. Yeah, it's yes. So thank you for watching this.